Hello, all lecturers, students, and participants. Welcome to attend Second International Conference on Innovative Technology, Engineering and Science 2020. I'm presenter Walisijiang Tayier. Today, I would like to talk about my research about evaluation of heat input and bed geometry of zincalume steel G550 welding joint between the metal inert gas and the laser beam welding. This is the problem sections. In the problem sections, two different problems found in the study. First is number of steel company enormously produced zincalume steel which experiences generation of substantial volume of waste. Second is finding suitable method to reduce the waste. In objective sections, the lap joint configuration using different welding parameters in the MIG welding. On the other hand, lap joint configuration using different welding parameters in LBW process. This is a literature review sections. This is a research methodology sections. Two different welding techniques is participate in the welding. First is ytterbium fiber laser and MIG welding. The zincalume steel, they consist of 55% aluminum and 45% zinc coated. So this zinc coated steel, it must be used in the roofing industry in the tropical area because of the zinc coated steel has able to resist of corrosion. This is a methodology process. First is lap joint clamping and welding MIG and LBW. After welding, grinding and polishing, and cold mounting and microscopy. In the microscopy sections, two different geometric shapes identified that the bandwidth and penetration. This is heat input value for MIG and LBW. This is equation for heat input calculation. The figure 1 compare diagram for heat input between LBW and MIG. So the welding speed is decreased, heat input is increased. While figure 2 compare the relationship between heat input and welding speed during the LBW and MIG. That the MIG process produced the highest heat input value than LBW. The figure 3 indicated the figures for effects of different heat powers on the heat input in MIG and LBW. The figure indicated the MIG produced higher heat input energy in the weld pool. So the weld pool produced highest perlite element than LBW. That means the welded pool became harder than LBW. The table 3 is analysis of variance for heat input. That the table indicated wire speed and welding speed must be a significant factor in the study. While figure 4 in signal noise ratio also indicated the wire speed and welding speed must be important significant factor in the study. This is value of geometry for MIG and LBW. The figure 4 indicated comparing diagram for bandwidth and penetration during MIG and LBW. That the bandwidth must produce highest bandwidth produced in MIG than LBW, but the penetration is deeper, produces deeper in the LBW process. The figure 5 is comparing bandwidth and penetration for MIG and LBW at constant welding voltage 70.5 and constant laser power 245. So the figure also indicated wire speed is increased, the penetration is increased. For LBW, the welding speed is decreased, the penetration is increased. In discussion part, I highlight the main point in discussion. First is high welding voltage generates high heat input energy. Second, 245 of laser power is produced deeper penetration. Ferrite phase is observed in the study. Bandwidth increasing from 3 to 4.699 when the wire speed increase in MIG. Why LBW produce high size of bandwidth at 245 of laser power? So this one is a wire speed increase, the penetration is grows from 0.699 to 0.813. So its penetration also increased from 0.245 to 1.60 when the welding speed decrease in LBW process. So the wire speed and welding speed is both significant factor in the study. In conclusion sections, I highlighted also is main point that the heat input increase when the wire speeds and welding is increased. 245 laser power is produced deeper penetration. The wire speeds is increasing deep penetration in MIG, and depth of penetration increase when the welding speed is decreased in LBW process. So the greens is increased significantly due to the fast cooling rate, which leads to formation of columnar greens in the fusion zone. Thank you for everyone for listening my presentation.